You might not see it, but right now there's a silent revolution reshaping the very heart of the world's biggest tech companies. It's not about a new app, it's not about a flashy gadget. No, this is a war being waged in silicon, an arms race to build the custom brains that are going to power the entire future of AI.
And it all starts right here. Microsoft just unveiled its Maya 200 chip. Now, this is not just another processor. It's a piece of silicon that has been engineered from the ground up for one single purpose: to run massive AI models as efficiently as possible. It's their first big shot in what's becoming a huge industry-wide trend.
Of course, Google's been in this game for years, right? They've been developing their own custom tensor processing units, or TPUs. They're already on their 7th generation. And now sources are saying they're teaming up with chip design giant MediaTek for whatever's coming next.
And it does not stop there. Meta is working with NVIDIA on its own custom CPUs. And deep inside Apple, there's a project codenamed Baltra, cooking with Broadcom to create custom server processors for Apple Intelligence. You see the pattern here? This is no coincidence. It is a coordinated strategic shift.
So this brings us to the big question, right? Why is every single one of these hyperscale companies pouring billions of dollars and just immense engineering talent into this frantic race? Why not just buy the best chips off the shelf from companies like NVIDIA? Well, the answer lies in a very special kind of chip.
The key to this entire puzzle is a concept that's actually been around for decades, but has suddenly become the hottest thing in all of tech. So let's talk about what an ASIC actually is.
Okay, so an ASIC is an application-specific integrated circuit. Now, unlike the general-purpose chip in your laptop that can run your web browser, a spreadsheet, a game, you name it, an ASIC is custom-built to do one thing and one thing only. But, and this is the important part, it does that one thing with absolutely breathtaking speed and efficiency.
Here's a great way to think about it. A general-purpose CPU, that's like a reliable family sedan. It's versatile, it can do your grocery run, it'll take the kids to school, go on a road trip, no problem. An ASIC, on the other hand, is a Formula One engine. You can't take it to the grocery store, but on the racetrack, its one specific application, absolutely nothing on earth can beat it.
And building that F1 engine is, well, it's no small feat. It is a hugely complex process. First, engineers have to describe everything the chip does in a special hardware language. Then, that design gets synthesized into millions of tiny little building blocks. After that, those blocks have to be physically placed and connected. And finally, you run countless verifications before it's ready. It's a massive, expensive undertaking.
So if it's so difficult, why even choose this path? This brings us to the core battle: designing your own custom silicon versus just buying it off the shelf.
You know, this quote from Microsoft's Scott Guthrie really says it all. 30% better performance per dollar. When you are operating at the scale of a Microsoft or a Google or a Meta, a 30% efficiency gain isn't just a small improvement. We're talking about billions of dollars in savings and a massive competitive advantage.
So here's the trade-off. The pros are just immense. Performance that's perfectly tailored for your needs and lower costs when you're doing things at a massive scale. But the cons, they're daunting. We're talking huge upfront engineering costs, longer development times, and you need a world-class design team. For years, only a few companies could justify it. But then, the explosion of generative AI completely changed the equation. The needs of these models are so unique and so immense that for these hyperscalers, the pros now just overwhelmingly outweigh the cons.
But here's the twist. These tech giants aren't actually building these chips all alone in some secret lab. They're the architects, sure, but they rely on a really complex global ecosystem of specialized partners to bring their designs to life. So let's take a look at this ecosystem.
Okay, this chart is fascinating. It shows the demand for a very specific type of advanced chip packaging from TSMC, who's the world's leading chip manufacturer. Now, if you look at the bars for companies like AMD, Broadcom, and others, that's the everyone else category, you'll see that demand is projected to absolutely skyrocket. This is the physical proof of the custom silicon arms race.
So the crucial point to understand here is this. Companies like Google and Microsoft, they operate on what's called a fabless model. They design the chip's blueprint, but they outsource the incredibly complex and mind-bogglingly expensive manufacturing process to a foundry like TSMC.
But there's another layer here. In between the tech giant and the manufacturer are these design service partners, companies like MediaTek and Allchip. They're kind of the secret partners that help Google and Amazon with all the intricate details of chip design and logistics,
turning a concept into something you can actually manufacture.
So here's how it all fits together. You've got the customer, that's the hyperscaler, like Google, who needs the custom AI brain. They work with a design partner, like a MediaTek, to finalize the blueprint. And then, that blueprint gets sent to the manufacturer, the foundry like TSMC, who physically creates the chip. It's a team effort.
All right, now that we understand the what, the why, and the how, let's look at what this all means for the future of AI, and really, for the future of computing itself.
So how big is this shift going to be? Well, take a look at this number. 3x.
That represents the projected growth in shipments of these custom AI server ASICs by just 2027. This is not a small trend. According to Counterpoint Research, we are entering a true hyper-growth phase for custom silicon.
And why should this matter to you? It's simple. This hardware arms race isn't happening in some far-off vacuum. These custom-built brains are going to power the AI you interact with every single day, from the intelligence in your search results to the next generation of assistants on your phone and at your job.
Which leaves us with a final, fascinating thought. You know, for decades, we've relied on these general-purpose chips that could do pretty much everything pretty well. But as every major AI workload now gets its own hyper-specialized F1 engine-style brain, are we witnessing the end of one-size-fits-all computing as we know it?